So, welcome everyone to day 3 of the TruBlo Demo Days, where we talk about outcomes and learnings. And today we have two interesting projects from quite different domains. First will be D-SBOM, which is for a distributed software bill of materials, meaning a contribution to software security. And Rohit Bohara, the CTO from Ashwin, will talk about where they are. Rohit, maybe as a start, can you talk a little bit about yourself?
Yeah, so I did my bachelor's in computer science in India. And after that, I started working in Bangalore with LG Electronics for embedded system. And after that, for 1.5 years, I worked in South Korea, also with LG Electronics. And I came back to Bangalore and worked with AMD for silicon verification. And then I realized working for big companies, it's exciting in the first year. And after that, it gets monotonous. So I decided to go to university. And I landed here in Stuttgart. I studied at University of Stuttgart. And I came here 2016 October, and in November I met my co-founder Miko Ross in one of the tech meetups, and that time he still has another sister company. It's called Digital Works. I started working with Digital Works as a student job, and in 2018 when this company was co-founded, I was there from day one, and I took the position of CTO at Ashwin. So let me give you a quick overview of what Ashwin does. So we have a lot of cybersecurity projects and cybersecurity products, and we also do cybersecurity managed services. This company was co-founded by Miko Ross and Sven Ralphs in 2018, and we are located here in Stuttgart, Germany. Most of our employees are also based in Stuttgart. A couple of employees, they are based in Brussels, which are from our innovation team, which they look on the standard and regulation area and the proposals or calls which are coming out of Europe for funding. And then we have another wing of Ashwin, which we call Ashwin Lab. And that in Ashwin Lab, we focus on cybersecurity projects, on research projects, and mainly the focus of these research projects is cybersecurity, specifically IoT security, AI security, and automotive security. Since last year, we have received funding of 3.9 million euros of public grants until 2026. And we have research partnership with MIT, KIT, and Fraunhofer Institute. So at Ashwin, we do the product development which focuses on cybersecurity, and also at the same time, we are doing research and development work where we got the funding, or we apply for the projects for national funded projects and for EU funded projects. So our topic is security of the software and how D-SBOM can help on this. So to start, the problem that we have identified, or the platform for this, is that software currently is getting more complex. And to put this into perspective, the Apollo 11 mission, which landed the humanity on the moon, it had around 145,000 lines of code. And this luxury car that we run nowadays, which runs on our highways, it has around 100 million lines of code. So if you see how much complex our software has become, and if you see the studies, then for per 1,000 lines of code, 0.5 to 3 errors occurs, even after doing a lot of pen testing, a lot of security testing, and all types of testing that is done on the software. So the software which is delivered to the customer, it has around 0.5 to 3 errors per 1,000 lines of code. And if you calculate it, if you do the math for a car which has around, let's say, 100 million lines of code, it would have 50,000 to 300,000 errors in that software. And by another study, it shows that to fix a high severity vulnerability, it takes around 250 days. So it tells you that even if you have infinite amount of resources, you cannot first find all the vulnerabilities which are there in the software. And secondly, you cannot fix them all. Therefore, and because of that, the challenges that we see in that it has given the rise to the supply chain. Nowadays, our software, that when I say they are complex, it's not only because the lines of code which are there in these software, but also how many different software libraries and packages are included in these small software. So there are hundreds of third-party libraries and proprietary libraries and other libraries which are included in these softwares. And we don't know exactly where these libraries are coming from and what dependencies these libraries might have. So a software has direct dependencies and transitive dependencies. And if you are using any third-party application, third-party library, it might have even more other direct and transitive dependencies. So because of that, our supply chain has become quite complex of software supply chain. And in this supply chain, even if there is a one weak link, it can be dangerous for the whole supply chain. And this is the risk that we have at this point, that there has been rise of supply chain attacks. Our supply chains are getting more and more complex. And policymakers, they have realized this part, and they have come up with a lot of regulations. So last year, there was a regulation from White House executive order for the supply chain security in USA. And they have now, NIST has made it quite clear that if a company wants to sell a software to any of the federal institute in US, they need to provide a software bill of material. A software bill of material, what it is, it's like, it's a list of all the software libraries and the packages which are included in a software. So it contains the name of the package, what is the exact version of the package, and what is the hash of that particular package, which could be used to uniquely identify that package. So that is the software bill of material. What we have done in D-SBOM project is we have developed a plugin, and we have also developed a platform. So with that plugin, we can integrate in the CI/CD platforms like GitLab and Azure pipeline. And from there, for each software version which is developed, which is built and tested in the CI/CD pipeline, we could generate this software bill of material, which contains the list of all the software packages which are included in this particular software version. And from there, the security doesn't end there. Once you have created the software bill of material file, then you also need to securely distribute this file or share this file with other stakeholders in the supply chain. And that's where this platform comes in, which has 5 different parts. One part is the D-SBOM plugin, which is used to generate the software bill of material, then sign the software bill of material, generate some other cryptographic hashes and signatures, which can be used to uniquely identify the software bill of material file. From there, we store this information on IPFS server, which is peer-to-peer protocol network file system. And once we store any file there, it generates a unique identifier for that particular file. It's called content identifier. So this content identifier and other metadata information of the software bill of material file we store on blockchain. So in this project, we had a partnership with Elastica community, and our the person who was supporting us on this project, he also works at Elastica, and that's where we use Hyperledger Besu network from Elastica community, and it was quite helpful to get all this information put all this information on the blockchain and get back the trusted information from the blockchain. So once we store the file and the metadata information on the blockchain, then we had built a D-SBOM portal where all this information can be visualized. customers. They can register all their software versions. They could see what different libraries and packages are involved in for each software version. What is the signature of these software version? They could also check, like what we had seen last year with the Log4j, that customers or the organizations, they didn't have any idea if their software used this Log4j library, and that was a big problem for us to find out. So we on our D-SBOM portal, there is a functionality that you could just put in any library name or a version, and with that we could show which software version include this particular package or library. So from there you could get all this information. So this visualization and also this trusted, unbroken chain of trust of each software version and for each software bill of material file can be seen on our D-SBOM portal. And all these 4 components of our D-SBOM architecture are secured with this authorization server, which is used to generate access tokens and to generate the login information and to authorize users to access this information. So our project was in OpenCall 2, and we also did a lot of dissemination work, which included writing blogs, social media posts, going to conferences, and we also in the end wrote a white paper where we described all the technical information and all our motivation and how we have worked on the goal of TruBlo project. So all this information was included in our D-SBOM white paper. Finally, I would like to proudly say that from idea to product. So in the end, after the project, unfortunately, our project didn't go to phase 2 of TruBlo, but still we were able to make this idea into a product. So now it is part of our product, and the name of the product is PawPrint. And in this PawPrint, which is under Beehive umbrella, which is where we have all our cybersecurity products, under which we have now released PawPrint, and it's market ready. And we since 6 months we have been selling this product. And on that part, I must say that TruBlo has helped a lot in terms of, first, we just had an idea when we wrote the proposal for TruBlo, and in the phase one of the project, where we from ideation to we went to how the technical architecture should look like and what should be the business plan. What we did the market study also. So these kind of activities that we did in the phase 1. From there, it was easier for us to go to the implementation phase, implement all the ideas that we had and what we had designed in terms of technical architecture. And from there, in 7-8 months, then we were able to release it as a product. So I think that was quite a good achievement for us. That's all from my side, and thanks Mirko for inviting us here.
Sebastian, we had quite a few interactions by now, but I am still not entirely sure what your upbringing was that got you from where you were before to becoming an expert in content standards. Maybe you can say a few words about your background.
Okay, good. Just a few words about my background. So I actually have been working in book publishing. So my background is coming from an industry that has gone through digital transformation quite significantly, and that was the starting point. Working on ebook distribution, digital distribution, data analytics projects for small or large media organizations. We set up the entire chain of ebook distribution and the accounting of these books sales. And that was also the starting point of the work on the ISCC, the International Standard Content Code. So it's a project that originated in German book publishing, where we faced the situation that identifiers like the ISBN are manually managed, and there's not a stable binding between the actual media asset, the digital file, and the identifier and all its metadata. So that was the starting point for me, and we started the work on the ISCC in 2017. It was also a blockchain project that originated this identifier, and went through all these stages at ISO to eventually end up as draft international standard. So if you go on the page of ISO, you can already buy the standard. And we are currently, you can see the life cycle, see that we are the last draft international standard ballot has been initiated and will be ending on the 8th of January. So we are very excited that after 5 years of ISO work, which I chaired as the convener and project manager, together with experts from 29 countries, are finally getting closer to the point of approval and publication. So it's pretty cool. So, and that was the starting point, that we have this this identifier, and what that would allow is not only to basically have two entities being able to generate the same or a similar code from the media file, even if they don't know each other, even if they don't exchange information beforehand, even if they have never discussed the media asset, but also to kind of attach information to that identifier, and that was the project that Liccium kind of has been working on and suggested to build an application where creators could basically manage their data that they want to associate with media content that then can be derived by third parties. So that was the starting point. The two parts of the project refer to the original name of the project. Very simple, DC for declarations and credentials, because that was these are the two main parts that we could develop in the course of this project, to actually generate the ISCC codes and then apply metadata and other claims to the content. And so to speak, the main issue that we had from the beginning of the in discussions around ISCC is anyone can generate the code. So if you have an image or access to a text file or a video, or you can generate the ISCC and make a claim. And the question is, who has the authority? Who is there a way to attribute the claim to an identity? And that was where we have been using the verifiable credentials standard to attach to the content declaration. So it's a combination from two relatively novel standards. One is the ISCC, and one is the verifiable credentials recommendation by the W3C. The starting point of the problem statement was what we can see all over the internet. So we have content floating around, being shared, being published online with no whatsoever identification. We don't know who's the creator, who's the rights holder, and we have no idea about licensing terms in most cases. So it's very hard to find out what you can do with the content, where it comes from, what it is, what the title is. And during the course of the TruBlo project, the AI, generative AI discussion exploded. Which accelerated the dimensions of that problem. So if we look at that slide, it has been widely shared and often presented. Only the models based on Stable Diffusion have 1 billion media assets being shared and published and used per month. So these numbers are staggering, and we find that situation on every platform, on the web, on social media, and these are kind of examples that I created to show, like a situation where this image is being shared, and there's no attribution whatsoever. There's no identity. There's no way to find out what the source of this image is. And if you use a Google image search, you will find out that this is one of the most used and most popular images that have been used. But how do I find out the original source? And let me do the fast track to get information about that. So, which is one part of the project that we developed, is like this plugin. It's a browser plugin that picks up the images or content. It also works with text. Currently, we will make it work with video and audio files. And you can select this, and with one click, it takes one and another click, you are at the point where you can actually find the original source, the original metadata, and the way how to license that image. So this is absolutely novel way to approach this kind of verification, to go on to explain the steps very simply. So the application client side takes the image and generates an ISCC code, and then compares it with ISCC codes that have been previously declared. And we have then sending back from the database, from the index, all metadata that have been provided by the original rights holder that are associated with that. And so you can see, like, title, description, this was the redirect link. This is a claim that the declaring party, which was in this case me, does not claim to be the original creator. So this is important because anyone can make any claim. And there's a distinction between, I will show some examples, whether you make a claim, a statement that you are the original creator, or that you have rights to that. But you could do that. And some photo metadata, if you're working in news journalism, you know IPTC photo metadata that provides you with information whether this is actually human-generated content or AI-generated content. This model, I will get back to the credentials in a second. This is a use case that shows what the ISCC distinguishes from any cryptographic hashing. So because first you have two images, and if you want to verify this image that someone shared here, you basically go take that image that feels strange to you, and then you have the information and get redirected to the original source, which has this kind of lamp in this example. So what that distinguishes the ISCC is that if you make a modification of the image or of the content, if you remove the metadata, which happens all the time when you share content on Twitter. metadata gets stripped away for security reasons. So cryptographic hashes do not work in real life. And we've seen a lot of projects where timestamping crypto hashes were promised as a solution, but it's in fact does not provide any value in decentralized media environments. So this is like one example. The other examples are, I mean, this is a pretty significant problem here, that AI-generated content has been offered by Adobe, and you can see it here in the websites, in the domain, that it's been used without any kind of attribution, without any kind of reference or so on. So how do you know that this is AI generated? So what you do is you take the plugin, you select the image, and it will tell you, oh, this is trained algorithmic media. So, and the original source where that has been sold is the Adobe stock photo website, where especially this particular image has been removed in the meantime. So Adobe stopped selling AI-generated photos, although this is still there. So I couldn't find a place where that has been actually used, but it's crucial to be able to quickly identify that content has been AI generated or not. And here, this is maybe my last example in that domain. So it's quite quick. You can see it's trained algorithmic media. And in this case, I made a declaration that points to the Know Your Meme website, where you can read about that that meme and the how that kind of came into existence, so people could get informed. So that could be one way to use the Liccium application, that you make declarations in order to tell a story about a specific content that you don't necessarily own. Maybe the last one thing, I think with the clams, that could be one thing to have unverified declarations and verifiable declarations, and these are verifiable credentials that basically, like in this domain verification, prove that the wallet who made the declaration is actually in control of the domain that is mentioned here. So I would say this is quite a secure way to provide a bit of reference and attribution to the content declaration. Let me jump into the application so you can see what we actually built, apart from the plugin, which is kind of the way to resolve and retrieve information. The Liccium application, you can connect with your wallet, sign in client side, so anyone can use the application and make a content declaration. And you know, 1 second, that should, yeah, it takes a while. Amazon AWS woke up. So, and let's go through the entire process. I think we have 3 minutes left. That should do. So I take an image. I generate the ICC code now. So this is what is the result of the upload. So you have a bit of asset information, you have the ICC code, which is not really relevant for a human person, and then you can provide metadata to that. And here in this case, that was let me choose I can I'm looking for a redirect page. I take the Wikipedia page for that case. So what you can do is you can provide a title, photo from Arlington, and then provide a redirect URL. You can provide a license if you like as a rights holder. So these are very basic basic information that you can provide. And if you are and say, okay, I'm the rights holder, then you save this information. If you want to provide additional information to the content, we thought if you are a band or if you are a photojournalist, you have different metadata that you want to provide. So what we will provide are plugins. So currently, this is addressing photojournalists that have IPTC photo metadata and a way to opt out from AI training and text and data mining, which have been activated, but there are a couple of other plugins in the making. And per media type or per content, you can then decide, okay, I want to provide IPTC photo metadata or answer the question whether the content can be used as AI training data or not. Let me make some changes and add the time 1546 as a kind of information, and say that this has been actually original capture sample from real life. I cut it into square, so that is original media with minor human edits. And I say, no, I don't want people to train on my content. So this is basically this is it. And now you can make a blockchain declaration. I accept the terms and then I digitally sign the blockchain declaration, which is at this point on Ethereum Girly testnet, but you can make live declarations on Ethereum mainnet, on Polygon mainnet, on Polygon testnet. This takes a few seconds in order for the transaction to go through. And the cool thing then is that you can go to any kind of page. I hope that this will work now. This is the moment of truth. And select this image here and resolve all the data that we just in a second ago provided. So it's human-generated content declared by the original rights holder. These are my two verifiable credentials. And you can see here that 1546 was the CT time when I actually made that, that declaration. And applied all the credentials and kind of analyzes whether the content that has been found on Instagram matches the content that has been declared. And we can see that the content, the perceptual content, matches 100%, which is the reason why we actually found it. The cryptographic hash and the data hash is different because social media, Instagram cut off metadata, compressed the data, did whatever transformation, but we still are able to manage. So we have a real life decentralized database that can be updated in real time and provides all the necessary information for content to be analyzed.
So
did I forget something?
Just
Maybe
for clarification, the washing picture was uploaded by you because you made it on a trip to Instagram?
This is 1 week ago.
Yeah, but
I didn't make any declaration for now, but it doesn't matter when you make a declaration because the identifier on Instagram is owned by the content, so it's there already. It's already tested by other users. So here we have an image by a photographer. And I mean, this is like me making this declaration. this is the verified domain of the original creator, and the original creator can, for instance, make a redirect to her homepage where she has other horse images, or where you can buy the license and stuff like that. And if I made a different redirect or provided other information to that image, but claiming that I'm not the original creator or rights holder. And the whole system is quite fast. The search would take about a few milliseconds to generate the code to query the database of up to 300 million ICC codes we tested. So and then provide the results back to the plugin. And with all the metadata, so it's quite efficient and it's quite fast, because we don't search for the content, we search for the binaries of the ICC codes.
Okay, so it doesn't go to photo data, but numbers data.
Exactly, it's these ICC codes that are decomposed into the different components, and then it searches for same or similar similar content, and it's relatively stable to in the context of like fake information. I have a couple of examples like here. So there's an image, and if you use that one to you will see that there's some kind of a leak. So we have like this image as the original, and then the Scheveningen city council said, okay, we need to do some modification on that. No, I'm joking. So, but this is like the degree of similarity that is where there would still be a match, and so you can verify and lead to the original source. That's the point of, if something seems strange to you, like this, or what's that? There's 2 clicks. You're 2 clicks away to be directed from the original location of where the original image has been declared.
Mm.
So it's quite effective. And what we're trying to achieve now is to have users actually make these declarations. So it's the application is live, so on Liccium.app, and you can use it, and I can give you some invite codes for that to test it. You can make declarations on these 2 networks, and even if it's let me just say this one thing. So what are we doing on the blockchain? Basically, it's 3 elements. One is, okay, it's the signature of the wallet that declared that, and then it's only 2 things. One is the ICC code and the link to the declaration. So okay, these are the declaration metadata here. Photo from Arlington, 1564. So they are accessible, and this is very efficient way to kind of provide the metadata to that ICC code, and it's fully decentralized. Anyone can search the blockchains for ICC declaration events. They are identifiable and resolvable, so anyone can also run a registry. So not only anyone can make declarations fully decentralized, but also anyone can resolve all information without permission. So you don't need to search for in a specific repository to find this verifiable declaration. And in a way, that was the reason why we had to include the verifiable credentials as a way to provide identity to any kind of declaration, in case we have conflicting statements, conflicting declarations, or unverified declarations that stand out significantly to, let's say, cryptographically verifiable declarations.
Can you tell a little bit how do two different declarations achieve some similarity? That doesn't get into my head.
Yeah, I can show like this example that I use, and this is more or less the technical view of the ICC. Let me go back one slide, which shows the ICC. So here you can see this is the canonical ICC code, and these are components of the ICC code. And the instance code is the checksum. It's a cryptographic hash. So if that is actually identical in rare cases, then you can be sure this is the exact same asset. But all the other components are sim hashes, similarity preserving hashes, and that observe the content and describe the content here in terms of the data encoding, the perceptual content, and the metadata which is embedded. If metadata is stripped away, the ICC still works, but it doesn't have a functional metacode. It doesn't matter. So you can use only individual components. And for the matching, in this case, you see that none of the three components, metacode, data code, or instance code, match. They are totally uncorrelated, but the content code is 2 bits of difference in a 46 similarity hash, which is most certainly a hash. And per media type, we have different ways of generating these 64-bit hashes. I think there's here, this is how, just an example. So you pre-process the content in a way that happens when you click on the browser plugin, by the way. Yeah. So you take the original source, you convert it to grayscale, you reduce the size, you do some discrete cosinus transformation, you kind of shift it and have a look at the frequency, and then generate this binary hash. And this binary hashes, they can be compared extremely fast. So if you have millions, hundreds of millions of these binary codes, you can compare how many zeros and ones are same and similar, and you take the ones in images that have up to 16 bits of difference. Otherwise, you would get false positive matches in this case. So it's a system that works pretty well for all media types regarding conversion of file formats, compression. But each format has different issues as well, to be clear. So for instance, currently rotation doesn't work. So if you wouldn't be able to match an ICC code when the content has been rotated. So these are the components, and the question, the interesting question is per industry sector, what are your use cases? And what we can see, like for photographic news industry, we have fake news, we have the topic of AI. With the music industry, they have different use cases, and book publishing. I've been part of a working group on anti-counterfeit products or counterfeit products, and combating counterfeit and piracy. So where the problem is that cover images are used to offer fraudulent content. So cover images of popular bestsellers and so on. So these are, and the main use case, I would like to mention it if I have 1 minute, is the AI opt-out declaration currently. So that is for all media sectors, all membership organizations around the world. They are, this is of main concern, and this is for the project has been a major driver, so that it's possible to attach the opt-out declaration, which is machine readable, which aligns with Article 4 of the European Copyright Directive, and this is super important. It's part of the of these images here. Let me take one of maybe my content, so not to flame So here it says, content must not be used for AI training purposes. And this is a machine readable way of having the ISCC code and the opt-out declaration. This is number one. Number two is that the new AI Act will require AI providers to create lists of copyright protected works that have been used for training. And I would assume there is only one way to do that using ISCC code. Why would they do it? Why would the AI providers use ISCC? Because for each output that they generate, like for these 1 billion images per month, they will generate ISCC codes. Why would they do it? Because before they train, they need to make sure that they don't train on their own output. Because that is what happens when you train on your own material, that you and all of the platforms have an interest to mark and identify AI generated content for the others and for themselves, not to train on their own models. And my assumption is that before they input the content into the AI systems, they will also check whether the original creators have provided an opt-out declaration to the ISCC code. So I think that this system is one potential solution for 3 problems using one standard.